A small steam pump made by Don English. This is an old demo model from Blackgate's Engineering and I want to make it work. It's sat for quite a few years on top of a cupboard in the shop. This is a very early version of the steam pumps that Don English makes commercially. The current version of the small boiler feed pumps made by Don English are considerably different to this one. And once upon a time when Don used to produce this type of pump, I bought about 3 of them to put in model steamboats or just sell on. But unfortunately the early versions of this pump were problematic. There was nothing wrong with the water side of the pumping operation, the bottom part. It was the steam cylinder part of the pump that always caused problems. For instance, it was always very important, even if you were running on compressed air, to lubricate the pump using steam oil, because inside the pump it has a small shuttle piston which operates the second of the slide valves, and this is fitted with silicone rubber O-rings which get sticky if you use any other kind of oil other than steam oil. And in this clip, as you can see, I've filled the displacement lubricator, but I'm not going to run it on steam just yet. As you've just seen, to lubricate the pump for compressed air running, I've just squirted some steam oil into the fitting that goes on the end of the airline. In this clip, I'm using ordinary lubricating oil for lubrication of all of the external moving parts. And now, when I turn on the compressed air, well, nothing really happens. The pump goes to the bottom and just stays there. So I wonder why it's doing this. Well, I know why it's doing this. It's very, very common. The shuttle valve inside the pump is stuck. Time for some drastic measures. In the outer part of the workshop, as you can see very clearly, I'm warming up the steam cylinder using a blowtorch. The logic being this may just free off the shuttle valve, but I'm not overheating it, I'm just warming it up. It's hot to the touch, that's all I need it to be. Because the pump is unpainted, it's okay to do this. I'm not applying too much heat anyway, but if the pump was painted, I certainly would not do this. Back in the inner part of the workshop, I connected the compressed air line, and guess what? It didn't work. So here comes the fun part. I'm going to dismantle the engine to make it work. The first thing to do is to remove the top cover. This is held with 2 very small bolts. No gaskets to contend with, it just has a layer of sealant. So what am I doing here? Squirting it with WD-40. When in doubt, squirt it with WD-40. In this case, I doubt if it's going to do anything, and in fact it didn't. So I turned the pump upside down, forgetting entirely that on the board that the pump's attached to is a water tank with water in it, so the water went all over me, and it serves me right for being stupid. These small bolts are very fiddly to remove, they really are tiny. Also, it's quite difficult to show this in detail on camera because my hands are very much in the way and they're a bit big. But as you can see, very slowly the bolt has been removed. Eventually I use the spanner and a screwdriver point to just rotate the bolt and get it out of there. I think it's a good idea at this stage to get a red plastic box to put all the parts in because they are very small. The entire valve assembly is held to the steam cylinder using 4 studs. And in common with all the work I've come across from Don English, the machining tolerances are very close indeed. This is the first valve chest coming off. And here is the very small slide valve that's just fallen out. Look at the size of this, it's tiny. The valve rod has some flats milled onto it so that the slide valve stays in position. And once again, the machining tolerances are very fine on these small pumps. Here you see how slide valve number 1 operates, and the other block that's left on the engine has a port face with 3 holes in it. I think at this stage I'll just put some Loctite 603 on the stud, refit it into the block, and the Loctite 603 should be fully cured by the time I put the pump back together. I'll be able to remove the nut without the stud coming out of the block. Note that I'm removing any surplus 603 because I don't want it to stick the parts together. This is the top view of the second block, and this is what's inside it. It's called a shuttle piston. This controls the second slide valve, and the first slide valve that you've already seen admits steam to both ends of this alternately. The effect is that even though this looks like a single cylinder engine, it has 2 cylinders. And that means that wherever the pump stops, it will immediately start when you admit more steam to it. I've made a girlfriend joke many times on the statement, this is fiendishly clever and very simple, all at the same time. I'm going to modify this shuttle valve very slightly. It's lightly held in my 3-jaw chuck and I'm taking a very tiny amount of metal off the end of it. Not all the way across though, just around the edge. Then my lathe started playing up. I think it's a 3-phase converter. It can't decide whether to apply boost or not to apply boost. I'm going to phone Transwave and get a spare part for it and see if it works. Really, when it's making a noise like this I should turn it off, but I need to finish the job. And suddenly, as soon as the intermittent boost started, it stopped and everything went back to normal. As you can clearly see at the moment, I'm cleaning up the end of the shuttle piston using some wet to dry sandpaper. This will make the shuttle piston's body a little bit smaller. I didn't show this part of the operation because I forgot to press record, but I removed the O-rings, then fitted the shuttle piston back in the chuck and used a needle file to just deepen the groove slightly. Just a very tiny amount of clearance to allow the O-ring to move around freely. Really, I don't think that was the problem, but I thought, well, I don't want to have to take the pump apart again if this doesn't work. I fitted 2 new steam-grade silicone O-rings and refitted the shuttle piston into the cylinder, and it does seem to be moving a bit more freely with less resistance. I'm reassembling this pump initially without any sealant whatsoever. I want to make sure that it works, and if it does, I will dismantle the pump again and seal the joints. So all they are at the moment are metal to metal contact. It's that time now. I'm replenishing the water in the water tank, and now I'm applying some compressed air to the pump. I really love these small pumps that Don English makes. They're absolutely wonderful. You don't need to use a steam regulator with them. You just shut the water valve and the pump stops. Open it again and the pump starts. In this small demo unit, the valve on the outlet simulates the pump pumping against pressure like it would in a boiler. In this case though, the valve is fully open and there's a good flow of water coming from the pump. You will also notice that this tiny pump is fully double acting. It pumps water on each stroke. And here, once again, I'm restricting the flow and you'll notice that the pump slows down. It's still pumping though, pumping very well. But as I start to close the valve, and this is almost shut, it's restricting the flow, and look how slow the pump's going. Why is the pump now working? Is it the O-rings, or is it the fact that I relieved the end of the shuttle piston at both ends? When a shuttle piston travels all the way down its cylinder, when it slams into the cylinder cover, there's often no room for the steam to get underneath the piston to lift it back up. I've come across this with some southward pumps as well. So by machining around the end of the shuttle piston, as I showed earlier, this just gives a little bit of space for the steam to enter and push it back up again. And with these very small pumps using O-rings that can be attacked by the oil and get sticky, it's no wonder that these tiny 1/4 inch diameter shuttle pistons stick. After all, they are moving a slide valve with steam pressure against the slide valve. But now, thanks to a little bit of gentle witchcraft, it's working fine. In case you're thinking about machining your own version of one of these pumps, please bear in mind they're not that easy to make. Castings are available for similar steam pumps to this one from www.southworthengines.com. That's it for this tiny pump special. Thanks for watching and I hope you found it useful. Please take the time to visit my Main Steam Models website. Click on the section of the website that says Video Playlists. And by doing that, you will find it very easy to find other videos that you may like to watch.